Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So we will learn about the Business Mathematics Chapter 2, Mathematical Applications in Finance. Okay, we have two subtopics covered in this chapter, which is compound interest and annuity. We have 9 important terms in annuity, which is payment terms, interest period, term of annuity, annuity certains, forbearance annuity, other annuity, ordinary annuity certains, amounts of annuity, and present value of annuity. Annuity, what is annuity? So annuity is a fixed income over a period of time. So for example, if you get 200 a week for 10 years, so this we call it as annuity. So actually in annuity, we have some money like monthly rental payment, annual dividends, insurance policy payment, housing loan payments, which is every week or every month we need to pay or we get that money. So this involves annuity. So you pay them one large amount, then they pay you back a series of small payment over time. So that is annuity. Okay, so this is example of annuity. Let's say you buy an annuity and it costs 20,000 and it will return you to get 400 a month for 5 years. So for this example, we get 400 a month for 5 years. It means 400 times 12 times 5. So the money that we get is 24,000. Seems like a good deal. You get back more than you put in. So why do you get more income? 24,000. Then the annuity, the original cost of annuity is 20,000. Okay, because the money now is more valuable than the money later. Let's say that the money after 5 years, 24,000 is like 20,000 now. Okay, so the people you give the 20,000 to go invest and earns interest or do other clever things to make more money. Value of annuity. So let's see the effect of an interest rate of 10%. So we imagine that a bank account that earns 10% interest. So the 10% interest on 1,000 means 1,000 now could earn 1,000 times 10%. So we will get 100 in a year. So 1,000 now becomes 1,100 in a year time. So if we look at this figure, so 1,009, if we multiply then 10% and we plus with 1,000 and we will get 1,100. But if 1,100 we divide by 10%, then we get back 1,000 here. So 1,100 here is the next year same as 1,000 now at 10% interest. So the present value of 1,100 next year is 1,000. So at 10% interest, okay, from now to the next year, we multiply by 1.1, and to go from the next year to the now, we divide it by 1.1. Now let's imagine an annuity of 4-year monthly payment for 500. Okay, so the first one, we get the first payment is 500 in the next year. So how much is worth now? Means what is the present value for 500 for the first year? Okay, so we need to divide 500 by 1.1. Then the present value we will get here is 454.55. But if you have second payment is 2 years from now, how do we calculate that? So what we need to do is we need to divide 500 divided by 1.1 divided by 1.1. So if we get 2 years 500 for the 2 next years, So the present value now is 413 ringgit point 22 cent now. Okay, so the third and the fourth payment can also be brought back to today's value by using the same method. So for the fourth, we need to divide 4 times. For the third, we need to divide 3 times, 1.1. Then we will get the previous value there now. Okay, so finally, we add up all the 4 payment that we have here. Our first payment, second payment, third payment, and the fourth payment. So the annuity value that we have here is 1,584 and 94 ringgit. So we have done our first annuity calculation. So for annual payment of 500 at 10% interest was 1,584 ringgit and 94 cent now. Future value of ordinary annuities. Future value of ordinary certain. Suppose an ordinary annuity certain pays 1,000 a year for 4 years at 5% rate of interest. So we want to find the amount of the annuity at the end of the 4th year period. So the first payment pay interest for 3 years, the second payment for the 2 years, and the third for the 1 year, and the fourth is a cash payment. So hence, the value of the annuity as at the end of the 4th year is the sum of the 4 compound sums. So let me draw the figure for this question. So our 0 to first, let's say we annuity certain pays 1,000 is every year pays 1,000 until for a year. So how to get the future value as? Okay, so as for our first year is 1,000, which is from 0 to 1. So we have 1,000 here because power of 0. So for the second year, from 0 to 1 and from 1 to 2, so the power of n is equal to 1 now, then we will get our s is equal to 1050. For the third, s is 1102.5, and the fourth one we will get 1157.625. So our S4, we total up all of our S here, then we will get our S4 at the end of the 4th year is the sum of the 4 common sum, then we will get our M 4,310.125 ringgit. Present value of a ordinary certain. So consider the present value A of the annuity as the sum of the present value of the 4 payments compounded at 5% annually. So we consider A is the present value. So every year we get 1,000 here. So to calculate for A1, then we will get 1,000 times 1 plus 0.05 to the power of negative 1. So that we will get 952.38 for the first A. Our second A, we get 907 ringgit and 3 cent. For the third A, we get 863.84 cent. And for the fourth one, we get 822 ringgit point 70 cent. So in order to find for the whole A here, we add up all the value of A here, then we summarize sum of the A4, we will get RM 3,545 ringgit and 95 cent. So previous figure like geometric sequence with the first term of A is equal to 1.05 to the power of negative 1, and its common ratio also R is equal to 1.05 to the power of negative 1. So if we substitute this formula into the formula of geometric sequence, but we multiply by 1,000 because 1,000 we have every month, then we substitute the value of A and R into this formula. we get our A4 is equal to 3,500.45 ringgit 95 cent. This is the ordinary annuity certain formula. Starting with the R is the periodic payment of annuity. K is the annual rate of interest. M is the number of time interest is compound in a year. And R have a formula is equal to K over M, which is R is the rate of interest for each interest period. While Sn is the sum of annuity with the n interest periods, and An is the present value with n interest periods. So the future value is Sn with the formula of Sn equal to R multiplied by 1 plus I to the power of n minus 1 over I, and the present value is An equal to R times 1 minus 1 plus I to the power of negative n over I, and R is the periodic payment. So for the example 1, we want to find the future value of an ordinary annuity that pays 150 ringgit each month for 3.5 years is valued at 6% compound monthly. So first of all, when we get the question, we list down all the information that we have here. So the words ordinary annuity means the value of R, which is R equal to 150 ringgit. Okay, when we see the word each month, so it stands for R. Okay, while 3.5 is our T. So our I is K over M, which is K is the interest rate here, 0.06 from percentage. We convert to decimal place and we get 0.06 over 12. Okay, why over 12? Because it's compounds monthly, which is 1 year we have 12 months. So we get the I is equal to 0.005. Okay, then the formula for N is equal to MT. So our M is 12 multiplied by year 3.5. Then we will get N is equal to 42. Okay, so since this question want the future value, so future value stand for S. So Sn, the formula for Sn is equal to R multiplied by 1 plus I to the power of N minus 1 over I. So we just plug in all the information that we have here, our R, our I, and also our N. Okay, then we calculate for S42. Okay, F42 we will get RM 6,919.98 cents. Example 2. Deposit of 250 ringgit each are made into an account at the end of every month at an interest rate of 4% compound monthly. So find the amount at the end of 2.5 years. So we list down all the information we have here. So what each means the value for R, okay, which is R equal to 250 ringgit. So R is equal to K over M. So our K is 4%. We convert to decimal place, then we will get 0.04 over monthly. So our M is equal to 12. Then our N is equal to, since our T is 2.5 multiplied by M 12, then we will get N equal to 30. So since this question want to find the account at the end of every month, so we want to find at the end of 2.5 years, so we want to find the future value. So we use the formula for future value, which is Sn. Then we substitute all the information that we have here. Our R 250, our I is equal to 0.04 over 12, our N is equal to 30. Then we solve for it, we calculate, then we will get S30 is equal to RM 7,874 ringgit and 4 cents. Example 3. 400 is invested at the end of each 6-month period for 15 years in an account that pays 14% compound semi-annually. So find the amount in the account at the end of 15 years. So we have R is equal to 400 because we have worked each 6 months 400. So this is the value of R. So I is equal to 0.14, convert from 14% R here, divide by 2 because we compound semi-annually, so M is equal to 2. So N is equal to T, our T is 15 year, multiplied by M2, then we will get N is equal to 30. So since this question want to find the amount at the account at the end of 15 year, so we will solve for S30. So we plug in all the amount that we have here, which is R equal to 400 and our I equal to 0.14 over 2, our N is equal to 30. Then we solve, we calculate, we will get our S30 is equal to 37 ringgit, 784 and 31 cents. So the interest earned is S equal to R multiplied by N. So our S, we have find the S here is equal to 784 and 31 cents minus with 400 R multiplied by N 30. So we will get the interest earned is 25,784 and 31 cents. Example 4. Find the total interest earned is 450 ringgit is deposit every 3 months for 5 years at an interest rate of 6% compound quarterly. So find the interest earned. So we have R is equal to 450. Our I, we convert 6% to decimal place 0.04 because it compound quarterly, so our M is equal to 4. So our N is equal to MT, so our M is 4 multiplied by T is 5. Then we will get N equal to 20 here. So we substitute all the information that we have into the formula for S because we want to find the interest earned. So we find S20 first. Okay. So for this, we find S20. Then we will solve for it. We get S20 is equal to 10,405 ringgit 65 cents. Okay, so interest earned formula is by using S equal to S minus R multiplied by N. So our R is 10,405 ringgit 65 cents minus with 450 ringgit multiplied by 20. Then we get the interest in is 1,405 ringgit and 65 cents. Example 5. Find the interest value of an annuity that pays 150 each month for 3.5 years if money is valued at 6% compounds monthly. So we get our R here is equal to 150 ringgit. I equal to 0.06 divided by 12 because compound monthly. So N is equal to 3.5 multiplied by 12. Then we get 42 here. So because we want to find the present value, so we use the formula for AN. Okay, so we just plug in all the information we have here, which is R equal to 150. Our I is 0.06 over 12. Then our N is equal to 42. Then we will solve for it. We get A 42 is equal to 5,669 ringgit and 74 cents. Example 6. Leon won an annuity that pays 250 ringgit every 6 months for 2 years. So find the present value of this annuity if money is worth 12% compound semi-annually. So we have our R is equal to 250 ringgit. So I is equal to 0.12 over 2 is equal to 0.06 and equal to 2 times 2 equal to 4. Then because this question want to find the present value, so we use the formula of AN, which is AN equal to R multiplied by 1 minus 1 plus I to the power of negative N over I. So we substitute the value of R we know here Okay, R equal to 250. Then we solve for I, we get 0.06 and our N is equal to 4. Then we solve, we get A4 is equal to 866 ringgit and 28 cents. Exercise 1. You wish to receive an annuity of 800 each year for 5 years. So the annual interest rate is 10%. So what is the present value of the annuity? So we want to find the present value here, means we need to use the formula for AN, which is AN equal to R multiplied by 1 minus 1 plus I to the power of N over I. So we already know the information given to us is R equal to 800, N equal to 5, and I equal to 0.1. So therefore, we substitute all the information we have here. Then we solve for it, we will get AN is equal to 3,032 ringgit and 63 cents. Exercise 2. You wish to receive an annuity of 500 a month for 10 years. The monthly interest rate is 1%. So what is the present value of the annuity? So this question want to find the present value, hence we need to use the formula for AN. AN refer to present value. So the formula for AN is equal to R multiplied by 1 minus 1 plus I power of negative N over I. So the information given to us is R equal to 500, N equal to MT. So our M is 12 since this this payment monthly, and our T is 10. So we get N is equal to 120. So I equal to 0.01. We convert from percentage to decimal place. So therefore, we just plug in all the information we have here into the formula of AN, and at the end we will get the present value of this annuity. AN is equal to 34,850 ringgit 26 cents, which is D. Exercise 3. You wish to receive an annuity of 300 a month for 6 years. The monthly interest rate is 0.9%. So what is the present value of the annuity? So we also will use the formula of AN because the question want to find the present value. So the given information to us here is R equal to 300. So N equal to T6 multiplied by 12 because monthly here. So our I convert from percentage to decimal place is equal to 0.009. So our A, and here we just plug in all the information we have here, which is R equal to 300, I equal to 0.09, and N equal to 72. Then we will get our present value for this annuity is 15,846 ringgit and 35 cents. Exercise 4. You wish to receive an annuity of 1,000 a quarter for 5 years. The quarterly interest rate is 2.5%. So what is the present value of this annuity? So we will use the formula of AN because of the word present value here. So we are given R equal to 1,000, N equal to our year, T equal to 5, and since words quarter here, so our M is equal to 4. So we will get N is equal to 5 times 4 equal to 20. And our I, we convert from percentage to decimal place, we will get I equal to 0.025. So we just substitute all the information we have here into the formula of AN. And we solve for it, we calculate by using calculator, then we will get our AN is equal to 15,589 ringgit and 60 cents. Exercise 5. You wish to receive an annuity of 6,500 a year for 15 years. The annual interest rate is 5.5%. So what is the present value of the annuity? So we will use the formula of AN equal to R multiplied by 1 minus 1 plus I to the power of negative N over I. So we are given the value of R equal to 6,500, N equal to 15, and I is equal to 0.05. So we plug in all the information we have here and substitute into the formula of AN. And we solve for it and we will get our AN present value for this annuity is equal to 65,244 ringgit and 28 cents. Exercise 6. You have 10,000 and wish to receive an annual annuity for 10 years. The annual interest rate is 8%. How much will you receive each year? Okay, so means this also want to find the value. We will use the formula for AN. So we already know AN here 10,000 and wish to receive annual annuity. So our T equal to 10 years and our R interest rate convert to decimal place R equal to 0.08. So for this question, we want to find how much receive each year. Means words each here refer to the value of R. So we just substitute the value of A and that we already know here in the question 10,000. Our I is 0.08. Our N is equal to negative 10. Okay, then we will get the value of R is equal to 1,490 ringgit and 29 cents. Exercise 7. You have 6,000 and wish to receive a monthly annuity for 5 years. The monthly interest rate is 0.5%. So how much will you receive each month? So we will also use the formula of AN because we are given AN here, which is AN equal to 6,000. And our N is equal to T5. Okay, multiply by 12 because word monthly here and our I convert from percentage to decimal place, we will get I equal to 0.005. Okay, then we substitute this information into the formula of AN, then we will get the amount received each month is equal to 116 ringgit, which is D. Exercise 8. You have 15,000 and wish to receive a monthly annuity for 20 years. The monthly interest rate is 0.25%. How much will you receive each month? Okay, because we already know the value of AN, so we will also use the formula of AN equal to R multiplied by 1 minus 1 plus I to the power of negative N over I. So our AN here is 15,000 and equal to 20 times with 12. Then we will get N equal to 240 and our I is equal to 0.0025. Therefore, we substitute all the information we have in the question and we solve for it, we will get the amount received each month, which is R is equal to RM 83 ringgit and 19 cents. Exercise 9. You have 7,500 and wish to receive a quarterly annuity for 12 years. The quarterly interest rate is 1.5%. How much will you receive each quarter? So we will use the formula of AN because we already know the value of AN here, which is 7,500. Our N is equal to 12 times 4 equal to 48 and our I is equal to 0.015. Okay, then we substitute the value we have here in the question into the formula of AN. We solve for it and we will get the value of R is equal to 220 ringgit 31 cent, which is C. So this is the amount received for each quarter. Now we want to find R. Mary deposits RMY at the end of each month into an annuity that pays 4% compounded monthly at the end of 5 years. The annuity is worth 13,259 ringgit 80 cents. So we want to find the value of Y here. Okay, so we want to find the value of R is equal to what? Our I is equal to 0.04 over 12 because compound monthly. And our N is equal to 5, refer to 5 years here. Okay, multiply by 12 because monthly. And we get equal to 60. Okay, we will use the formula of Sn because is words. Okay, means word here refer to Sn. So our Sn is 13,259 ringgit and 80 cents. And we plug in all the information that we have in the question and we solve for it, we will get the value of Y is equal to 200. Example 8. Marina took a loan worth 30,000 at 2.5% compounds monthly and had to make monthly payment for 3 years. Calculate A, the monthly payment, and B, the total interest. So first of all, we list down all the information given to us in the question, which is AN equal to 30,000, I equal to 0.025 over 12, N equal to 3 times 12 equal to 36. So we just plug in all the information we have in the question, then we solve for it, we will get the value for R here. Okay, so the monthly payment R is equal to 865 ringgit and 84 cents. So the interest formula earned, we will use the formula interest earned is equal to Rn minus An. So our value of monthly payment, we already know from the previous equation, 865 ringgit and 84 cents multiplied by 36. Then we minus with the An equal to 30,000. And we will get the interest earned here is 1,170 ringgit and 24 cents. Example 9. Sabia bought a low-cost terrace house for 35,000. She paid a 10% down payment and the balance was borrowed from a bank that charged interest rate at the rate of 8.5% compound monthly. So this loan will be repaid in monthly installment for 10 years. So the question want to find the monthly payment and the total interest charge. Okay, so we list down the information we have here, which is AN equal to 31,500. Okay, because we minus from the low cost terrace house, which is 35,000, minus with 10% down payment. 10% down payment here means Sabia's already used her own money to pay to the bank from 35,000. So 10% from 35,000 is 3,500. So the balance from that is the borrow from bank. Okay, so 35,000 minus with 3,500, then the amount borrowed from the bank is 31,500. So this is the value for AN. Okay, so the value of I is equal to 0.085 over 12 because we compound monthly here. Okay, so we will use the formula of AN. Okay, because we want to find the value of monthly payment here. So we make our R, which is R is monthly payment as our subject. Then we solve for it after we substitute all the given information in the question. Then we will get our R is equal to 390 ringgit 55 cents. So the second question, we want to find the interest charge. Okay, so interest charge formula is equal to R multiplied by n minus with an. So R is the value that we have get from the first question. A, which is 390 ringgit point 55 cent multiplied by 120. Then we need to minus with the amount borrowed from bank, which is 31,500. Then we will get the interest and charge is 15,366 cents. Example 10. Muthu intends to accumulate 25,000 by depositing RMY every 6 months for 10 years into an account that pays 3.5% compound semi-annually. So find the amount of Y. So Y is R, which is monthly payment. We already know the value of interest earned 0.035 divided by 2 because compound semi-annually means our M equal to 2. Then we solve for it, we will get our I is equal to 0.0175. Then our N is equal to MT. So M is 2 times with T equal to 10. Then we will get our N equal to 20 here. So the accumulate means the value for Sn. So we solve for this question by using the formula of Sn. So we substitute all the information of Sn, I, and also N. Then we will get the monthly payment or Y is equal to Rm 1,054 ringgit and 78 cents. Example 11. Aslan gave his son Amir 10,000 3 months before the start of the new academic year in the university. So Amir deposit in the money into an account that pays 4% compound quarterly. How much can Amir withdraw at the start of each quarter if the money is to pay for his expense during his 4-year program at university? So we already know AN is equal to 10,000. Our I is equal to 0.04 over 4 because compound quarterly. Then we will get I equal to 0.01. So N is equal to T4 multiplied by M4. Then we will get N equal to 16. So we use the formula of AN here because we already know the value of AN. Okay, we substitute all the information that we have in the question, which is AN equal to 10,000, I equal to 0.01, and N equal to 16. Then we solve to find the monthly payment that Amir will get, which is R is equal to quarterly payment of R is equal to 679 ringgit and 45 cents. Next, we solve to find the amount of N. Example 12. Akim wants to have 2,853 ringgit and 35 cents at the end of a certain period of time. His plan is to deposit 100 at the end of each quarter into a fund that pays 6% compound quarterly. So how much quarterly payment must Jamal make in order to save 2,863 ringgit and 35 cents? So we already know the amount of R is 100. Okay, so because Akim wants to have, so want to have means the word of Sn. Okay, so our Sn here is 2,863.35 cents. So our I is 0.06 over 4, which is 0.015. So we plug in all the information we have here into the formula of Sn. So now we solve to find the amount of N. Okay, so we plug in all the information and at the end we will get 1.015 to the power of N is equal to 1.429505. Okay, so from here, in order to put N in front of 1.015, we need to add log for both sides, right and left hand side. We need to add log in order to put our N in front. So after we add log for both sides, right and left hand side, then we can draw the n in front from log. Okay, so in order to get the value of n, we need to divide because n here multiply with log. So log 1.015 go to the right hand side is become divide. So our n is equal to log 1.429505 divided by log 1.015. Then we will get n equal to 24. Example 13. A piece of land costing 240,000 cash is purchased by making a down payment of 45,000 and the balance is to be settled by making 120 months payments at 6.5% compounds monthly. So the first question, we want to find the monthly payment. So the information given to us is the down payment is equal to 45,000. So the amount of A here, A equal to 240,000 minus with 45,000, then we will get 195,000. So our I is 0.065 divided by 12, then we will get 0.01 and our N is equal to 120. So in order to get the monthly payment here, for the question A, we need to use the formula of AN. So we just plug in all the information we have in the question and we make our R monthly payment as the subject. And we solve, we will get our monthly payment R is equal to 2,240 ringgit and 19 cents. So for question B, we want to find the interest earned. Okay, so the interest earned is R multiplied by N minus with AN. So our R is 2,214 ringgit 19 cent multiplied by 120 minus with 195,000. So we will get the interest earned is 70,702.80 cents. So for question C, the buyer intends to settle the entire loan 8 years by making a single payment for this single payment. Okay, so 8 years here, so 8 means 8 times with monthly payment. Okay, so 824. Okay, settle 8 years by making, okay, so in order this payment is 120 payment. So for 8 years, 8 times 12 is equal to 96. Then 120 and equal to 120 minus with 96. So the balance of A that not pay yet is 24 here. Okay, so we find the amount of A24. So we just plug in the amount of R, which is monthly payment, we get in the first question. And our I is same as first question, which is 0.01. And our N is equal to 24 here. N is equal to 120 minus with 96. Then we solve, we will get the amount of A24 is 49,705 ringgit 42 cents. This means in the 8 of years, okay, this person need to pay 49,705 ringgit 42 cents in order to settle the payment. Example 14. Bahar bought a house for 5,000 down payment and has promised to pay a 200 quarterly for the 10 years. So interest is 10% compound quarterly. So this example contains of 4 questions. So let we look one by one. Question 1, to find the cash value of the house. So the information given to us here from the question is I equal to 0.06 over M quarterly. So our M is equal to 4 and our N is equal to 10 years, 10 multiplied by our M for quarterly, then we will get our N is equal to 40. So the down payment of 5,000 is not part of the annuity and has to be added to the present value of the annuity. Okay, so the cash value of the house is equal to the down payment plus with A40. Okay, so the cash price is down payment plus with A40, which is the formula for A40 is R multiplied by 1 minus 1 plus I power of negative N over I. So we plug in all the information we have in the question, we solve for it, and we will get the cash price is equal to 10,983 ringgit and 70 cents. For question B, if Baha is unable to make the first 12 payments, so how much will he be required to buy on the day of first 30 in order to cash up his payment? So we will use the formula of S here because Baha did not pay for the first 12. So we want to find the 13 payment here. So 13 payment is S30. So we just substitute the value of R12 200, I equal to 0.06 over 4 power of 13 because we want to find the 13 payment minus 1, and we solve for it, we will get S13 is equal to 2,847 ringgit and 37 cents. So for the question C, after making the first payments, Baha wish to settle the remaining debt with a single payment on the day on the 9th payment. So how much the extra payment that he must make? Okay, so in order to settle 40 payment, but at the 8th payment, Baha wish to settle the remaining in the single payment on the 9th payment. So 40 minus with 9, we will get 31 here. So we will need to find A31. So we plug in all the information we have. R equal to 200. So I also we know, M we know, and to the power of negative 31. So we find A31 is equal to 4,929 ringgit and 22 cents. So this is the amount that Baha need to pay to the next 9 payment if he want to settle the remaining debt with a single payment on the 9th payment. For question D, suppose that Baha does not make the first 10 payments, how much he pay on the day of 11 payment in order to settle the entire debt. So the payment is equal to the amount of the first 11 payment that he does not pay plus with the present value of the remaining 29th payment. So we need to find the total payment that Baha needs to pay is S11 plus with A29. Okay, so we just use the formula of S for the first one, for the first 11. So 200 multiplied with 1 plus 0.06 over 4 to the power of 11 minus 1 over 0.06 over 4. And at the end, we need to plus with the formula of A29. So we use formula for A, but the N is equal to 29 because of A40 minus with 11. Then we will get A29 here. So we solve for it, then we will get the total payment that Baha need to pay at the 11 payment is equal to 7,047 ringgit and 88 cents. That's all for the chapter of annuity. Thank you.